This morning I had the opportunity at a seminar to introduce the Assistant Secretary of Education for the United States Department of Education. And he talked in his speech at the seminar about how critically important advanced education and STEM education, science, technology, engineering, and mathematics is, not just to America's economic future, but to America's security and to global security and to global economics and to global health. And so as I read through the biographies of our three alumni, our three Great Minds panelists, a few minutes ago, this really struck me, how true Peter Cunningham's words were. I think maybe as I read through this, you'll see for yourself. Our first guest is Stefan Paige, class of 2000. Stefan is a petroleum engineer with the Shell Oil Company in Kiev, Ukraine. He earned a bachelor's in theoretical and applied mechanics and master's in aerospace engineering, both from the U of I, Urbana-Champaign. After graduating in 2005, Stefan started working for a major international oil field services company as a field engineer in Western Siberia. He worked his way across Romania, Bulgaria, the Ukraine, Georgia, and Hungary. After working throughout Eastern Europe for 4 years, he joined Shell as a petroleum engineer in the Netherlands. He was responsible for the development of a number of technological innovations for producing late-life natural gas wells. More recently, he moved with Shell to the Ukraine and joined a major project for both Shell and Ukraine, who are on their own drive toward energy independence. Our second, Mark Wrzyszczynski, is from the class of 1992. Mark also hails from Shell, but in a different capacity. He is a subsea project manager with Shell Projects and Technology in Houston. He earned a master's in business, an MBA, Master's in Business Administration from Tulane, and a bachelor's of science in mechanical engineering from the U.S. Naval Academy. After graduating from the Naval Academy, Mark served in the Navy as a submarine officer and qualified as an engineering officer for a nuclear-powered ship. He joined Shell in 2001 and has worked a variety of positions at Shell, building infrastructure and oil and gas developments in the Western Hemisphere. He is the inventor of record for a patented subsea structural clamp and coordinated Shell's recovery in the Gulf of Mexico after Hurricanes Katrina and Rita. He has served as the chair of Offshore Operators Committee, Pipeline Subcommittee, and is currently working with the Subsea Tyvek Foundation, the Educate Committee, to encourage careers in the subsea energy industry. And we also welcome Alex Surasky-Ysasi. Close. Thanks. Class of 2003. Alex is a design engineer who has already worked in a wide variety of fields, from American steel plants to rural Tanzanian agriculture. This includes work for ANZA Technologies designing a low-cost pushcart for farmers in Africa, as well as the development of local capacity to produce small-scale electric turbines in Guatemala with the appropriate infrastructure development group. She is passionate about human-centered design and the ways in which technologies, old and new, have the capacity to transform lives in the developing world. Alex's design philosophy is that tinkering, observing, hands-on prototyping, and listening are key components of the process. She received her bachelor's degree in mechanical engineering from Brown University in 2007. Those are our three great minds. I don't know if all of you had a chance to read the blurbs for their breakout session, but I'll close with this and then the quiz. One of our panelists wrote that the 21st century has been filled with innovation, from new technologies to new services. Entirely new industries have emerged. The call for innovation has never been greater. Simply put, business growth and competitiveness are dependent upon the capability to deliver creativity and innovation in their products. The United States has been synonymous with technical innovation in software and internet services, but there is a need for the U.S. to expand its strength in creativity and innovation to the wider, albeit maybe less exciting, engineering fields. These are fields in which individuals can make a lasting impact on the world and become enablers of wealth creation for society. The primary driver toward creativity and innovation in engineering is education. Historically, engineers were taught to use each new technology that appeared in industry. But today it changes so quickly that engineers cannot be just reactive. They have to be able to thrive with change, or their value will be eroded into a commodity on the global market. We cannot afford this risk. We have to discuss how individuals can ensure they end up as innovators and not become commodities, and how they will make a difference and an impact across the wide world. So, the quiz is, what do these three have in common? They have used, you got it, their creative, ethical, scientific minds to advance the human condition. And we are so proud of you for doing that, and so grateful. And again, welcome to our Great Minds panel. Thank you, our speakers. Let's hear it for them. And at this point then, this is a question and answer time. So like the legislative panels, we will ask you to line up with the microphones. We have plenty of good seating down here, so we don't have to have these long lines of 15 and 20. We'll keep 2 or 3 at a mic, but you can certainly queue up in the seats and make yourself comfortable. And we'll address a question to the panelists. We'll give each of the panelists the opportunity to talk, to answer your questions, and as well as while they do that, again, perhaps share some of their thoughts about what they have done, what needs to be done for engineers to advance the human condition. So, who would like to be first?
No. Hello. Okay, so this is more directed towards Alex because I went to your breakout session. But you talked about creating products or devices that are accessible to a large portion of people, especially in developing nations. But when you're considering design for those products, do you take into account the sustainability of those products and how those products, though they might be cheaper and easier to produce for the masses, especially in those developing nations, how that might have an effect later on in the environment and those types of things?
Yeah, you try to take that into account, certainly, when you design things. I won't tell you that it's a perfect system by any stretch of the imagination. The cart that I worked on, it's all metal because really if somebody absolutely broke it, they would sell it for scrap over there and they would get made into something else. In general, that's something that's at the forefront. But it's always a balancing act. It's absolutely a balancing act. To tell people that they can't have access to something consumable like you and I and maybe our cell phones, is that really fair? There's a really big ethical question there, So it's a very hard line to walk, and how do you balance all of those considerations? There are so many. So yes, it's certainly on our list of things. It's not the absolute highest priority, but you talk about product life cycle and what do you do? What happens to the product at the end of its life cycle? It becomes very important. It's something that design engineers, I think, pay attention to, not only when they design for the developing world, but more and more when they design for the first world as well. So,
thank you.
This question is particularly aimed at the 2 engineers who hail from Shell. Can you discuss the economic differences between Americans getting energy from an energy integrated corporation as opposed to a more raw corporation? And does that allow for more innovation and technology than simply a company that's working on procuring the commodity at hand?
Did you hear the whole question? What was the company that you wanted us to contrast? An integrated oil company?
Shell against a company that's solely focused on producing or obtaining the oil resource. As you said in your breakout presentation, Shell is focused on transporting and working engineering-wise with the product as well. Is there an economic difference between those types of companies?
I'm going to try to answer your question. I'm not sure that I understand it, but I'll answer it this way. There are companies out there who make it their business to just find oil. There are companies out there that make it their business just to produce coal. There are companies out there that make it their business just to produce electricity from nuclear power. Shell is an integrated oil company. I talked about this a little bit in our breakout session. They do all of those things, not the nuclear specifically, but they find the product, they find the resource, they produce the resource out of the ground, they transport the resource to a refinery where we cook the resource and make it into a usable product. Because prior to that, it's just raw materials. And then after it's a usable product, generally jet fuel, diesel fuel, gasoline, and chemicals that are used in all sorts of different things, we sell those products to the market. And the market can be individuals, the market can be industry, the market can be companies. But I think another question that we should ask ourselves is, who do we want to do that? Who do we want to figure out how the best way to get that resource to market is? Because how much do you think, how much of the world's oil supply do you think is controlled by Exxon, BP, Shell, Eni, and Chevron? Those are the 5 largest integrated oil companies in the world. Any guess?
Perhaps 50 to 70%?
10%.
Oh, wow.
Those 5 companies control about 10% of the world's oil. The rest of the oil is controlled by Saudi Aramco, Gazprom, Petrobras, Pemex, PDVSA. Those are government national oil companies. Now, as long as 10% of the resource is traded on the open market, we'll get a market price for it. But when that resource is no longer traded on the open market by integrated oil companies, who, I'm going to say this with quotes, just want to make a dollar, right? When that goes away and the resource is no longer controlled on the open market, what are we going to have? So think about who you want to control the oil in the world.
Yeah, I mean, it's an interesting question. So it's a bit, it comes to the history of the industry itself. So originally, in order to make a fair profit, I don't want to say fair, but in order to make a good profit, these companies, particularly these integrated companies, they needed to withdraw value from every step of the process. There wasn't, it simply wasn't the situation we were in now when the price of oil was 10, 20% of what it is today. So now companies are seeing that there's a capability. If you look at Shell, the vast majority of Shell's profit, and it's all these integrated companies, is made in the production of raw products, oil and natural gas. And companies are seeing that, okay, why am I even going to spend the effort to do all of the other stuff when the money to be made is there? So a more recent thing is these companies that pop up to just focus on this very profitable aspect. The risk you run into is, you know, for large companies, you end up with, you know, they end up getting their own, I suppose you could say, moral sense in how they do business. And the thing you start to notice is many smaller companies, it's not as important for their, and I don't want to say that's a reason why we should only let large companies do it, but it's a risk that small companies often don't have the same drive and the same importance to doing things with a safe way. It's difficult for me to say after we've all seen what BP did a few years ago, but the aspect is kind of like Mark said, a lot of these smaller companies, they do things solely for that bottom line at the end of the day. And that isn't to say we need to, because in many other companies, small companies like this can thrive and they can do so. But it comes through regulation that you need to ensure that everyone's playing at the same game. But there will be companies that are only interested in one aspect, because there are also companies that are only interested in that aspect of refining. And okay, now is not a great period for them to be operating in. But we don't need to. It's not like an integrated company is a better way of doing it, but we need to ensure that regulation is in place, and that's what the U.S. really needs, and where a lot of other companies, particularly in Europe, are ahead of the U.S., and that's where the U.S. needs to figure out that good medium to ensure a lot of the worries are being met.
Thank you.
All right. So my question is, how was engineering at IMSA? How was engineering at IMSA? Yeah.
It wasn't here.
There wasn't a class called engineering when I was here. I think the closest thing we had was applied physics, and that was a fantastic course. I think all of the courses that you're taking right now feed the mind that you have to have as an engineer. You have to be inquisitive, you have to want to understand why things are the way they are, and you have to have the imagination to understand things that you can't see. So I think the total curriculum supported my entry into the engineering major very, very well, even though we didn't have a course called engineering.
Boy, I may quote you on that. Alex, how about, let's go, you were 10 years or 11 years after that.
Yeah, I mean, we still did not have a course called engineering when I was here. I would say the closest I got to what we would call engineering was probably in the shop that's hidden behind the really nice Granger lab.
Oh, right.
There's a shop back there. There's a wood shop that's not quite so clean because they don't sequence DNA in it. That was the first place that I was really enabled to put my hands on some tools and fiddle and play with things. Certainly the classes set you up from a problem-solving point of view, but for me it was also the extracurriculars. That was kind of all the stuff in the shop was outside, and then to the guy that's taping the video up there, I was the idle kid in the back, and they let me tinker with everything. I got to play on every computer program, and that inquisitiveness, that drive, that just figure out how it works, because in class you learn how it works step by step, but when you walk into the real world and look at a machine, you don't know how it works till if you get to touch it, hopefully you do, but if not, till you stare at it and you figure it out. And so those opportunities in theater and in tech, actually, I found were really helpful.
How about the third world piece, Alex? What inspired you to do all this work in developing countries?
I see Dr. Cadle, thankfully, still sitting out there. I did my inquiry project in the history department. And for me, my mom's family's Cuban, and nobody exactly teaches Cuban history. And I started to learn about the history and the development of that country, and it led me to try to understand more and more what's happening around the world. And I became really interested in that, and really interested in the lives that people lead and the lives that they want to lead. And I became really passionate about that, because I think there are a lot of minds out there that spend every day just figuring out how to get by. And if we had access to all of that human knowledge, I mean, imagine what would be being made. Everyone in this room is fantastically smart and talented, but there's a lot of people that aren't in this room that are fantastically smart and talented that we don't even know. And so to me, that was kind of what opened up my eyes, a lot of the history and the context. And I never would have imagined I did a history inquiry project and it made me a better engineer, but I can absolutely say that's true.
Integrated learning, wow.
Yeah.
Well, I don't know who was first over there.
I guess this is directed more at Alex, but what is it like to be a woman in engineering? What are some of the challenges you've had to overcome with that?
Yeah. Well, I was very blessed. My mother was an engineer, which meant when she studied engineering, there were 3 women in her class of 50 chemical engineers. And so thankfully I had a really strong role model who I'm really proud of to this day. But things are different. You don't necessarily see things the way everyone around you sees them. There's a different perspective. And you have to be willing to be assertive. Absolutely. You have to speak up. You're going to make a mistake. You're going to say the wrong thing sometime. And that is okay, because being quiet means nobody hears your idea. Nobody bounces off of that. It's hard. Where I work right now, I'm the only woman in the engineering department. And you have to just kind of roll with the punches, I would tell you. If you can find a mentor, if you can find someone to hold on to and help you figure out how to do that, it's really great. But you have to just really believe in yourself and your core that you are as capable, even if you're the only woman in the room, as all those guys sitting around you, and your ideas are just as important and just as valuable to that team. The gender stuff, we don't approach problems the same way always. If we're going to stereotype, women sometimes like to lead from behind, and that's recognized more and more. And when I mean that, I mean like getting everything organized and making it possible for the team to push forward together. And that's being recognized, I'd say, more and more by companies as valuable, but you have to make sure you advocate for your value being recognized. Because when people realize it, they'll hang on to you like you wouldn't believe, and they'll come to get you to work for them and to work on their projects. So.
Thanks, thanks, Michaela.
Yeah. First, I have a question for Mr. Paige and Mr. Mark. and then I'll have a question for Miss. And after that, I have a question for Mrs. Surasky-Ysasi.
Good job.
Okay. So, Mr. Paige and Mark. So, you two have talked about what your company has done in the world, correct? I wanted to know, what have you two personally done?
We've done a lot of things.
Okay. Yeah, I mean, I've been, as mentioned, I've been working outside the U.S. now for 8 years, and it's something that I really feel that IMSA provided me, and that was the drive to learn, the drive to be able to understand, and it's really something that I feel is what I bring in. So it's, although I'm an engineer, it's not the technical aspect that necessarily is the primary thing that when I'm working in a team in all these different locations around the world. It's the capability to look at, I talked to my breakout session about innovation. It's the capability to think of a new way of solving a problem, and that I've done this without getting in quite boring technical speak, but a number of projects is coming in and working with a number of technical people, but getting all of those people to think about something differently. And I feel that's something that IMSA really did well, is giving that capability to think differently. The technical solutions I've delivered, okay, I mean, there have been, but I think many people can deliver technical solutions. It's this capability to innovate and think differently about a problem instead of coming at it from the bottom, coming at it from the side, from the top, is really something that creates a lot of value. And as Alex mentioned, it's what gets people that they want you to work on their team, that they ask you to come and help them, because you can help the whole team get to the final solution that in fact works best.
So you'd consider yourself a part of a greater whole, you're saying?
Essentially, yeah. I mean, it's a bit the role that I have. I mentioned one before. So I work in a team of essentially hard scientists, so physicists and geologists, and I'm the one engineer amongst this group. And it's a bit, that's my responsibility in this team, is to innovate these scientists that enjoy talking about it and getting the team directed towards a final goal. And that's what I feel that I do, is this integrator, this drive towards a goal. And that's a bit where I like to fit in, and I think I fit in well, and have been in a number of situations in a number of different countries doing this.
Good.
Yeah, I think it's a great question. And I could sit here and I could rattle off some information about pipelines that I've fixed and the patent that I've got for a clamp and some other technical details for things that I've specifically done. I've been the engineer responsible for a specific part of a project. But I'd actually answer your question with a question. What did Steve Jobs do? What did Bill Gates do? They didn't do any of those things themselves that have affected our entire world, but they put together teams and they've led teams to do something that has truly affected our lives. And so that's the role that I'm in now, is I don't do anything by myself. I am absolutely reliant on the people that I've assembled to work on the projects that I'm executing. So I don't do anything. I'm a professional talker. Right? That is, yeah. But I do motivate people to work safely and execute projects that really make a difference in people's lives every day.
Wow, thank you, Mark.
Hi. I'm thinking about doing a research project next year on the effects of offshore oil spills on underdeveloped countries. So I know you worked on the BP oil spill in the Gulf, and I was wondering, how would you propose a solution to that kind of problem when it's been happening in a country over decades?
That's a great question. And it really hinges on who is interested in the fact that that oil is spilling. You see, we had a leak down in, when I say we, I mean the industry, had a leak down in Brazil recently. It's called Frade, F-R-A-D-E, is Frade in Portuguese. And it was a Chevron project, and they spilled something on the order of 4 barrels, 160 gallons of oil. And there's no excuse for spilling oil, but when you think about the magnitude of that, and then you think about the response that occurred, Chevron executives were arrested. They were placed under house arrest in Brazil. They couldn't leave. All of their operations offshore Brazil were halted, and they are facing enormous fines, I think on the order of $40 million worth of fines. This is the response that's occurred in Brazil, and it's certainly affected the way all the operators are operating in Brazil, whether it be Chevron or Shell or BP or even Petrobras. The national oil company is changing the way they're doing things. Now, you can drive all the business out by doing that. And at the other end of the spectrum, you can go to the Nigerian Delta, where oil has been spilling for 20, 30 years, and there's been no response, and it's tolerated. And in fact, the locals attack facilities because they're not getting any revenues from those facilities. Both ends of these spectrums have something to do with what we call license to operate. It's the right to go somewhere and develop a resource. And it occurs in all different kinds of businesses, but it's especially important in the oil business because we have to go where the resource is. And so there's a right answer somewhere in between those two things. Now, the technical aspects of cleaning up an oil spill are really not any different in Nigeria than in offshore Brazil. But who's interested in making it clean, getting it cleaned up, and what partner do we have to execute that cleanup is a really important question to answer. I don't know if that answers your question. Maybe Stephen has another perspective.
I think that's good.
As Dr. McGee said, you guys are not commodities. As engineers, you have very exciting and important jobs. How did you get where you are today and make what you do really important in the engineering industry? It seems like the jobs you have wouldn't be everyday jobs that are easy to come by.
Wow. I went to IMSA, went to college, and I came out and I said, I need to do something really different. For better or worse, during college, because I was an engineer, I didn't get in enough Spanish class in time for them to let me study abroad. And I was really passionate about these kind of development projects, and I said, oh, I'm gonna go. I applied for jobs with a tiny nonprofit that, despite what their website looked like, was probably a total of 15 people, not super high funding. And I went. The most important thing you can do is to do, and to keep doing and trying, and to not be afraid. People are saying, oh, there are steps I have to take to get there. It's not always steps that are like proper training, and I could have stopped and gotten a master's degree, which they're great, and both these guys, I think, have them. But I haven't done that yet, because the first thing I had to do was just start and mess up, because I've done that. I've done that, and I've succeeded, and I've been very lucky, and there have been people around me that have helped me do that. But I would tell you that's the biggest thing. People wait to start. They think you need more credentials or something to start. It's not always the case. If you're willing to put yourself in an uncomfortable situation that's outside your comfort zone and try and listen and work, I would tell you.
Stefan, would you respond? You're the one that talked about the commodity versus the innovator.
Yeah. Yeah, I mean, it's, at some degree, I have to be honest, and I always say it, it's a bit of a cop-out perhaps, but a lot of where I end up has been by luck. I mean, my initial job offer where I went to Russia was by luck when I ended up getting my offer with Shell, but it's, you know, you always have to be prepared for the opportunity, because opportunity often shows up, and it may not be the most opportune time. Like Alex said, you may not, it may not be sometime even, say, from their perspective, the perfect fit. But if you know something you want to do, and I see this time again in my industry from other people I see, they know what they want to do. You have to go out and get it. I mean, you can't sit by and just wait while something's going to be dropped in your lap. But there are opportunities, and they're always appearing. But the most important thing is to know what you want to do. And arguably, initially when I went to Russia, I wasn't aware that I really wanted to go and get this opportunity to work in 9 different countries around the world. But the opportunity appeared, and I grabbed a hold, and I've continued on ever since. And I hope to continue doing so in the foreseeable future. But that's what you have to do. You have to prepare to jump on an opportunity when it appears, because a lot of it is luck. Many things in life come down to luck, but you have to be ready. You can't wait for something to appear. You have to be ready to react when the opportunity is there.
Great advice for everyone. Go ahead.
Sure, people. Okay, so I went to Miss Alex session, because I can't pronounce your last name. And I wanted to ask you guys what you guys feel your greatest accomplishments are. I know Mr. Mark and Mr. Paige, you guys consider yourselves part of a group that's on something. So what kind of things have you done, and what things are you most proud of?
Starting. I mean, there's a couple different things I'm really proud of. While I was overseas in Guatemala, I had the chance, we were incubating a business. And the people that were going to run that business, that were going to stay there, they're Guatemalans. I got to mentor a couple of them, a couple of young guys. And I think they're doing well. I actually don't hear from them too much, but I'm really proud of having spent that time with them beyond the workday and get to know them and what their lives are like and understand them and hopefully help give them direction. And here's the really dorky moment. I'm really proud of that cart that I've sent overseas that I know, I think we sent 1,000, about half of them have been sold. And even though I don't hear direct stories, I know that it makes a difference. I don't know how many more will ever be produced, but I know that there are farmers who have a better life because of that, and that that's more than I could ever really ask for. So yeah, that would be it for me.
Well, thank you. I'm going to keep this moving because we have a lot of people queued up. I know Mark and Stefan would like to answer that too, but I think it's okay.
Hi. Several times, I'm short. There we go. Several times throughout your speaking today, you've all mentioned the importance of communication, and you all work in international contexts. And so my questions pertain to communicating in international contexts. What unique challenges do you face through cultural, linguistic, or other differences, and what tools do you have at your disposal to make it work, in short?
Yeah. It's something I've got to think when I think I mentioned it over lunch. But so originally when I started out in Russia, so when I was at IMSA, I took German. In university, I took German, and I didn't speak any Russian, and they essentially dumped me in Russia in the middle of Western Siberia. And the first experience I had is I was sent out into the field. So this is Western Siberia, about 4 hours flight east of Moscow, the middle of nowhere. And I was sent out to see operational jobs on an oil well, basically. And I was sent with a number of people. One guy spoke a bit of English. He could kind of get by if he really had to. But I was in a truck with another guy. He didn't speak a word of English. He didn't even know the word yes. I mean, it was that simple. He simply didn't have the comprehension. And I didn't speak, I could say yes and no, and that's about it. I think I could say beer at the time, but not much more. So, I had to figure out how to communicate with this guy. We both needed to. And what amazed me, and I mean, this was my second week in the company, second week in the country, is that if you have a drive to do something, and in this case, it was a drive to communicate this guy, I was amazed the amount of communication we had. I was stuck with this guy the first time for 8 days straight. It was me and him in a truck, that's it, 8 days straight. And it was amazing. I mean, I knew about his family, I knew where he was from, I knew what he had studied, and he knew the same about me. We didn't speak a common language, but there was a drive to understand. We were put together, and we wanted to, and it became possible. And this comes up time and again. I'm in Ukraine now, and I'm working with regulatory authorities on improving the technical work scope that we want to conduct for these operations we're doing. And these individuals, they speak a bit more English than this guy did, but not much more. And at times I would expect, okay, it's a very bureaucratic country. There's going to be resistance to even want to communicate with me. But it's amazing that if people desire it, you really can come across. And so oftentimes, of course, we will use translators. But it's amazing what is possible if there's simply the drive to do it. And I've yet to really, in the 9 different countries I've lived in, I've yet to have a problem with communication or cultural differences that prevent me from dealing with someone.
Thank you. Good. Mimi, you
Hi. I have more of a broad, overarching question on the field of engineering. I've been telling my parents repeatedly that I want to go into research, and every time they say, if you want a job, you should be an engineer. And obviously, both fields advance the human condition, but in your opinion, how are they different in the way that they do so?
I think research is much more cyclic than engineering. We need engineers every day, 365 days a year, good economy or bad economy, because everything around us is engineered by somebody. This building was engineered by a building designer or architect, right? The cell phone on your hip was engineered. So if you don't mind the cyclic nature of research, I think it can be very rewarding and very exciting and very needed. But when we hit a bad economy and the research dollars dry up, you've probably heard that phrase before, it's very real. And if you're not well prepared to do something else during those times, it can make it difficult.
Thank you.
Why? When did you choose to become an engineer and why?
I've known I wanted to be an engineer since I was about this big.
I mean, I guess for me, I'm still not sure. I'm still figuring out. So I mean, it's for me, engineering. You know, the drive for me is not being an engineer. It's being an innovator. It's making things possible. And engineering happens to be something I'm good at from a technical standpoint. So I choose to do that. But I think the drive, engineering is great, and if people want to do engineering, they should. But what you should want to do is be an innovator, is take what IMSA is giving to you, take that understanding and the capability to learn and the capability to adapt. And it doesn't have to be for engineering. It can be for any field you choose to do. It can be for research. It can be for medical. It could be for art. Anything is possible, but it's taking that understanding. And if you're good from a technical standpoint, there's an enormous amount of engineering jobs, so that's great to do that. But there's also any other number of jobs that you could do. But it's taking that. It's being that innovator. It's applying the understanding that you've learned into whatever it is you do.
So I really want to be an engineer when I grow up, or like when I get older. So I'm just wondering, like, what do you guys love about your job, like being an engineer?
What I love about my job?
Well, yeah, what do you guys like love about it?
My favorite thing about my job, the coolest thing I do, I make something in a computer, I draw it in CAD, and someone makes it. And then hopefully if I did it right, it works. That's like when someone makes your stuff, when it becomes real, when it's not just in your mind anymore, I would tell you that's the coolest part about my job. That's the coolest thing that happens every day.
So I'm certainly considering becoming an engineer after going through college. And I was just wondering, after going through college, what do you feel that working at a company is rewarding? Or would you, I'd say, enjoy your job more if you were allowed to pursue your own interests?
Working for a company is both rewarding and frustrating. It will always be the case. The important thing when you look at, I mean, if you can go out on your own and that's something that you drive to do, and you can see many of these famous individuals that have done so, then that's great. But the important thing is find the right culture of a company that you can fit into. And for Alex, she's mentioned before, it's a 100-person company that's good for her. I've found an 80,000-person company that works well for me. But it's finding the right culture, and whether that's a culture that in my case, it's having that capability to innovate. But it could be any number of things. Alex mentioned over the lunch that it's her. It's the fact that she knows every person in her company. That's very important. And of course, I don't know 80,000 people in Shell. But it's finding the right culture. And it can be so rewarding to work for a company because of what's possible. And I mean, for me, the opportunities are endless. And if I choose, I can't just say tomorrow if I want to do something different, I can. But if I choose to deviate from my current career path, it is possible. There's so many jobs, and whether it's moving to a different company or even in the same company. But companies are so rewarding because of the opportunities you have, but it's really finding the right company, if that makes sense.
Thank you. I just add a little bit to that, Matt. I think just to build on what Stefan was just saying is there's not a right or wrong or better or worse to it. They're just different. And there are things that a big company give you that a small company doesn't, and vice versa. There's independence in a small company that you can really be the leader of a particular area of the company very quickly, whereas it takes a lot longer in a bigger company. There's security with a big company that may not exist in a small company. All of that will change. All your priorities with regard to that and risk will change if and when you get married and if and when you have children. And those two things really do affect your outlook on what's important to you. When you're young and single, you can run off to Western Siberia, and it's a lot of fun. It really is. You can join the Navy, see the world, quite seriously. But when you begin to develop a family, your priorities will change. And that's okay. It's not good or bad. It's just different.
We're running almost out of time now. Daniel, if you have we'll do this time for the last question. So, Daniel,
when I first read the descriptions of what the breakout sessions would be and your mini biographies for the presenters, I was curious as to why there were two people, both Stefan and Mark, who both had very similar backgrounds. I mean, you both went to the military afterwards, and then you both ended up working for Shell, and that made me wonder why, out of the over 5,000 students that have graduated from IMSA, were you three picked? And what did you bring to the table that made it special?
What a quinky-dink. I really have no idea. I'd never met Stefan before today, so I didn't know that there was another IMSA alumni that worked for Shell, let alone in the energy industry. To my knowledge, I don't know anybody else from my class that works for a major oil company. So I don't have an answer.
There was a little bit of distressed murmuring as I came up to the front, and I think that's because the students are alarmed that an English teacher has decided to ask a question at this point. I'm thinking about this particular question in response to the fact that my husband, who tolerates my being an English teacher quite handsomely and bravely, happens to be himself an engineer. He's a computer engineer. He works in, he's a Scrum Master and a DBA, and everything he does is sort of in this digital world. And he happens to work in a work environment where he is developing code on the spot for his users because it's a completely proprietary arrangement within a law firm. Here's the question. Whenever I talk to my husband about his job, he says that the reason why he's good at his job is because his job is really all about human nature. And that in order to be able to build anything, the first thing you need to understand is human nature. I find this fascinating because I think of my discipline as basically the study of human nature. And I'm wondering if one of you could respond to that idea.
To answer that question, I think it exists on two levels. One, when you're working with the team, you have to convince people to buy into your ideas, right? So there's that human nature aspect. You better believe that in a company of 100 people, I bring cookies in to be on my machinist's good side, because I'm going to screw up a part, and I'm going to have to ask them to make it again, and there's that. And then the other part is understanding who you serve and what they need. You know, these guys serve all of us in making it possible for us to drive our cars where we need to go every day. And their whole company has to anticipate, to a certain degree, not just our behavior, but the whole world's behavior with regard to how we consume energy. Well, I also have to do that when I go out and talk to a farmer about how they're going to use my push cart. So it's the same problem. It looks really different, but it's about understanding people and what their needs are and what they might think to do with this thing that you're considering making. You know, there's a lot of anticipation and sorting out all the possibilities that are there. I don't know if you guys...
Yeah, I mean, I think it a lot comes down to, so there are many engineers that can be told to design a widget, and they design a widget. And that doesn't take a lot of creative, that doesn't take a lot of innovative thinking, but it's I keep coming back to my favorite word, innovation, and that's what it's about. If you need to be able to put yourself into whoever your, I'll use the term client, whoever it is you're delivering something for. And there could in fact be many different people on one thing that you're delivering. You know, in my case, that happens a lot. So, I'm delivering a technical aspect to the company I work for, but at the same time, I'm delivering an environmental request to the regulatory authorities, and at the same time delivering a request to an NGO about the water usage that we want to make. And it's being able to put yourself into all these individual people and understanding what it is they want. So you can't always please everyone, but you can understand where they're coming from and what it is they're looking for. And this is the challenge of being an engineer. It's not being able to do a technical design and make something look like someone tells you to. It's being able to understand when someone, particularly a non-technical person, makes a request, making sense out of that request and actually delivering to them what it is they need. And this is what a lot of very successful technology companies, they already know what people are going to want in 3 years' time, and they've already been working on that aspect, And there's of course the as-you-go type coding, like you say, of your husband. But it's those aspects. It's understanding, put yourself in someone else's shoes, and that's what an engineer really needs to be good at.
Probably the most important thing that your husband does is he can communicate with lawyers. And I mean that quite seriously. We have a lot of IT folks that cannot communicate with the end user, the people that need a product. My neighbor directly across the street, he's been hired by Shell specifically to do just that, because our IT programmers have trouble talking to our geophysicists. All right? They don't talk the same language, and they don't understand each other's needs. So he is a mediator, and that's the value that he brings to the table. So as Stefan was saying, you can be the most brilliant person in the world, but if you can't sell your idea or understand and communicate with your customer, you won't ever sell that thing that you're looking to build, and you've got to have it.
Well, let me just close here. I hope you saw two things. I hope you saw what great minds are and what great minds look like. And we've had this program, this idea of Great Minds program. And I think this afternoon we've seen the resourcefulness, imagination, creativity, innovation. We've seen risk takers, communicators, not just problem solvers, but problem finders. That's what distinguishes these great minds. The second thing I hope you saw is yourself sitting here 5, 10, 15 years from now. Because I guarantee that you sat on these same steps many times and probably never thought that you would be here. And but you are. And across Illinois, across America, Friday afternoons are often reserved for pep assemblies. And believe me, I love football maybe even more than the next person. But I'm walking away this afternoon so inspired, not just about what you do, but about what IMSA means and what a gift it is to be able to work with you students, to work with the faculty, the staff, and to see what a difference that you as individuals have made in the world. And I'm so proud of this place, but this Friday afternoon I wouldn't trade being here for any place in the world. I am so grateful and so proud, and thank you for all that you have done to advance the human condition.